Okay, here I have a new setup with several changes. First of all, there is an electrical heater who the Arduino will control by this feedback sensor, so it could hold the steady temperature. And also I can measure the input power to the system. I have done that once before for many years ago. But I didn't measure the pressure volume diagram at that time. Now I will do that. You may wonder what this is. This is an air pipe who actually is an automatically, this is a simple homemade air electrical air valve, who also will be controlled with the Arduino. So the Arduino tracking the movement of the displacer and could adjust, increase or decrease the amount of air in this. So it's always on the sweet spot for the displacer. I have shock valve here, so I replace the long charging pipe with only this shock valve. This will of course be replaced with the rotary water turbine and the generator later. But the nice thing with replace the driving pipe with water turbine or this shock valve is that I could read the volume change outside the container, and I know then the volume inside the container. I don't have to calculate what's happened at the check valves, what that release, and the bouncing effect of charging energy in the long charging pipe. I actually have done this for a long time ago when I made a very large, not so very large, but about 20 liter larger engine where I have a stove on top and burn some wood. I have only a shock valve like this, so I slow down the frequency to about 0.2 hertz. It worked well, but I didn't measure any pressure volume. I just see the principle works. The displacer I'll change so that I have a lid here, just like the large one, so the air will be forced because the water level is there, so the air will be forced through all the punch. Now I have punch hole through this glass foam, so the air will go through all these holes, and that will be the regenerator height. And the benefit with that is that there will be the moving part. The displacer here will actually have a better temperature ladder of the regenerator, instead of when these move and the air go on outside, it will be some sort of more mid temperature. So there is a benefit of having the regenerator inside the moving part. Of course, you don't use this distance to the outer container is just dead volume. You don't use that for regenerator, and that's of course the disadvantage. But I think it's better to force the air to go through the displacer if you have a very flat displacer and large stroke, because then the temperature gradient and will be not so good if you go outside the displacer. All right, you will see later when I put all these things together. And last test I didn't know actually what the mean temperature was, because the pressure volume measure was not correct. I didn't know actually what the volume change was. Now I could know that, and I could calculate the mean temperature. I tried to estimate it but it was difficult. Maybe it was a 100 something 20 degrees or so. I have done for many years ago a test with similar, where I have a heater and insulate that and measure the total efficiency, about it, very low efficiency. Overall efficiency was 2.05%, but that was very low. I have 133 degrees on the top. I don't know actually what the mean temperature was inside. Of course it was lower, but and then I measure also the total pumping output pumping water. So there, now I've measured the direct pressure volume, and I will maybe crank up the temperature to a little more, to 200 degrees or so. Okay, we will see how this works through. Bye bye.